Hello? Is that okay? Good morning, everyone. This is a really good group for 9 a.m. on Monday for thesis reviews. Sometimes we don't have as many people this early in the morning, so thanks everyone for being here. We're going to kick off our very first Master of Architecture thesis presentation. We'll be in this room the whole time, flipping between this side and that side. The third student for the morning is on the back of that panel, so once we rotate, we'll be on that side for two presentations. And we're going to introduce our jury. We'll have you guys introduce yourselves because you know better than I do. And then we'll pass it over and kick it off. Does anyone have any questions about the process of the day? The only, I guess, unexpected component is that Eileen's chair, Marcus, is on Zoom. So at the very end, we'll have a Zoom interlude from Marcus on Zoom. So do you mind starting introducing yourself? Thank you.
Hi, I'm Catherine Anderson. I am a faculty at George Washington University Interior Architecture Design Program. Yes, I'm here actually with my colleague, Stephanie Travis.
Hi, I'm Stephanie Travis. Yeah, I'm I'm program head of interior architecture at GW, and I'm very happy to be here. We've been here for a couple of things over the years and have some friends that are professors, so I'm excited to see the work.
My name is Michael Marshall. I'm an architect in Washington, D.C., have a firm there, and I've been coming to University of Maryland since, I think, 1996. You were here. Yes, for quite a while, and the key professor 1 year. Very excited to see the work.
Hi, everyone. I'm Dana McKinney-White. I'm an assistant professor of urban design at the Harvard GSD, and I started my teaching career here at Maryland, so I'm glad to be back. Thank you.
Hi, everybody. My name is Carlo Achilli. I am a coordinator of architecture program in the Florence program. I'm here for the third time. The first time was 7 years ago, so I'm very happy to be here again and to see a lot of friends here.
Hi, I'm Daniela Senacropi. I am Carlo's colleague. I work in the architecture department at the Florence, the ISI campus. This is my second time here, and super excited to be back and meet new colleagues and see old friends.
Good morning. My name is Craig Spangler. I'm a senior principal at Ballinger and 1982 graduate of the school, and I was a key professor in 2012.
Thank you all for being here. It means a lot to us, to the faculty, to the students, to be able to have these conversations with you. Each student will have around 20 minutes to present, then we'll have a follow-up conversation, and we'll conclude with a message from the chair, who will be on Zoom this time. And otherwise, if you have any questions, you can let me know. You can let Brian know, or anyone that looks like they know what they're doing. Okay, whenever you're ready.
Okay. I will start by saying thank you for everyone that helped guide me through this thesis. So my name is Eileen Garcia, and today I will be presenting Printing Hope, Addressing the Affordable Housing Crisis. Today, I plan to cover the affordable housing crisis, 3D printing construction, site selection and analysis, and building design and construction. So my research question is, how can 3D printing technology help address the shortage of affordable homes to meet the needs of low-income residents in Maryland while elevating the standards provided by code regulations of the built environment to create a sustainable and resilient future? So, home is a place where one lives, rests, feels comfortable, feels protected, performs daily activities, and fosters life. Having a place to call home brings one to a place of comfort and stress relief. Unfortunately, not everyone has a place to call home. Attempts to help aid this issue can be seen through affordable housing developments. Housing is considered affordable if it costs no more than 30% of the monthly household income. For rent and utilities, if the cost of housing is over 50%, households would be considered severely cost burdened, leading to continuous stress for its residents. So over the years, there has been an attempt to increase the construction of housing units, both for sale and for rent. However, it has not been sufficient in keeping up with the housing demand, creating a housing shortage of 3.3 million homes. This housing shortage has led to an increase in home pricing, creating a decrease in home ownership. Another negative effect is that it creates a burden on renting units, and the government isn't able to assist all the residents in need of affordable housing. Providing affordable housing is a key to reducing intergenerational poverty and increasing economic mobility. The average time to produce a new residential unit has increased over time, proving that there is a need for another approach to the construction process. The average time it takes to construct one unit is about 10 months. A 2 to 19 units, 19 months, and 20 units or more, 21 months. So for further analysis, looking at the time frame for different construction phases of a single-family 2,500 square foot home, we can see that the construction process phase that takes the longest is the core and shell, due to all the disciplines being involved and relying on one another to move the construction forward. But if we look towards 3D printing construction, everything has been coordinated during the core and shell construction. Time frame is reduced significantly to less than a week. So that would help eliminate 9 weeks in the construction process. Another benefit of the technology is that it allows homes to be built at a lower price. And this is because that core and shell process is all happening at the same time and doesn't need other components. So reducing the cost of construction by $8.23. So to put this into perspective, that $2,500 home would be a decrease of $20,000. Not only is it cheaper to build, but it's also cheaper to operate. From an analysis of the units designed, that will be covered later in the presentation, the EUI of the units allowed for a decrease of 70% of the operation costs, relieving its residents from being cost burdened. So the limits of the current technology is that it requires a 4-foot spacing around the construction of a home, and it's currently only able to print up to 3 stories, but there will be it's still new and it's still advancing to larger sizes. So the way the 3D printer starts the construction is by pouring the foundation. Then 3 layers of concrete walls are printed together, allowing space for plumbing and electrical to be placed between the walls. And then before placing the precast concrete roof, or roof, the walls would be infilled with insulation. Some ways in which 3D printing construction is elevating the standards is by creating resiliency against fires and floods. It has increased strength and its lifespan by being able to withstand up to 8.0 magnitude earthquakes. It has a tight building envelope due to the 3 concrete layers and the insulation infilling the layers. It is very environmentally friendly because of the built up of the concrete being created by green cement, which reduces emissions by 99%. Finally, it increases natural daylight by having access to windows on all sides of the print due to the constraint. So the location of this site is located in Greenbelt, Maryland. It's very close to Washington, D.C. and College Park. It is a city that has been growing with a lot of opportunity and is projecting growth over the years. So that's one of the reasons why I chose the site. But a major reason is because in 1937, Greenbelt was created as one of the first 3 green cities during the New Deal, in which it looked towards new construction methods to keep up with the housing demand. The development consisted of modern modular construction, also found within historic Greenbelt. Within historic Greenbelt, there's also an Art Deco style, which helps blend nicely with the curves of the 3D printing construction. This was some of the inspiration that led to the contemporary design of the construction. And then these are some values that were created for green cities, which was used for inspiration when designing the spaces, specifically creating connected communities and housing for all. So as we zoom in to Greenbelt, the city is divided mainly by the highway and creates a division of sub-communities. On the plan, we can see the site is located in Greenbelt East, and Old Greenbelt is located north of the site, which contains the historic district. To further study how the original development attempted to create a green city, a further analysis is created of the historic district. So the site is divided into these large super blocks, which is surrounded by all the amenities at the center of the site. The reason for creating the super block was to limit road access and increase pedestrian access, so having an interconnected woven system. And then if we see more of the block, we can see that the housing is divided by an entry side and a garden side. The only issue is that the privacy created between the units is very limited, only having privacy at the garage level, at the garage entrances. So this is very difficult also to implement this type of sizing block into other suburban development areas. My site is located in Greenbelt East. So the site is surrounded by the highway. It is mostly residential with a central park where the community has generated its own community garden. So the community is already looking for more community spaces as the closest recreational center is located in Old Greenbelt, and the only way to access it is either a 40-minute walk or a bus ride. It has few amenities on site, which is located north of the park. So surrounding the park, the site was developed in between the 1970s and 2010s. However, the development has created a very disconnected development of Greenbelt East, as some developers have even fenced off the areas of housing, and really the ideas of the historic district are lost of creating a connected community. So to help mitigate this, the first step would be to increasing density to create more affordable housing. Second, the 3D printer constraints would allow for more cross ventilation. Third, creating a more public front area that reconnects with the street front. And fourth, creating more community public gathering spaces that doesn't sacrifice the privacy of its users. So along the main route within Greenbelt East, there would be a development that reconnects the street with the existing residential building while giving back to the community more green spaces and community flexible spaces. There is now a ring road, a new ring road that wraps around the space, around the park, similar to the historic district, where there will be future development of a recreational center that anchors around the existing residential housing. The development would be divided into 2 phases, in which the first phase starts to reconnect the neighborhoods with new streets, incorporates a park, and continues to create a buffer from the highway. It includes 16 co-housing units and 50 stacked duplex units. The second phase continues reconnecting the streets and creates more housing and includes a space for a recreational center. This phase has 14 co-housing units and 24 stacked duplex units. So, welcome to the new Greenbelt East development, where there is housing for all, creating an improved green city that has more social opportunities and reconnects with nature. The street front contains new bus stops along the main road in East Greenbelt. All unit blocks have indoor and outdoor flexible spaces, which can be utilized for a makerspace, educational learning space, or recreational space. The types of units found on site range from 1-bedroom to 3-bedroom and co-housing units. All units include a VRF system and VRF system for cooling and radiant floors for heating. For the stacked duplexes, an owner would be able to rent the other unit to help decrease the housing costs, so relieving some of the cost burden of the users. These units also operate using solar panels, reducing cost of operations as stated earlier. The first floors are 1-bedroom units for each, and for the smaller unit, the upper floors are 2 bedrooms, and for the larger units, it's 3 bedrooms. So the cost to create these units allows for the ability to create more space-friendly units compared to what is existing in the historic district. Finally is the co-housing unit, which consists of 4 bedrooms, a large kitchen, workspaces, and gathering spaces. And there is a fireplace on each floor that creates a space that is the heart of the home for its users and encourages more interaction for its users. This unit includes solar panels to help manage operating costs. So the disconnection between the units allows for natural light to enter more into the units. It allows for the reduction in sound transmission, which was a major issue in the historic Greenbelt since the prefabricated homes allowed for a lot of sound transmission. And it allows for an increase of cross-air ventilation, reducing cooling costs. And to conclude, I say, let's print hope to help create more possibilities for the American dream while creating a more resilient and sustainable future. Thank you for listening to my presentation, and now I open the floor to questions and comments.
Everyone can hear on Zoom. We'll use a mic to ask questions.
Great layout and great presentation. Just a couple questions. The space in between the buildings. It looks like it's not like maybe like 4 or 5 feet. And so you think the air will be able to come and go through?
Yes, so I looked at the kind of like the air wind flow.
Yeah,
And
the direction you mean?
yes, the direction. And since the units are kind of like angled, it's able to kind of enter through the sides.
Because it's so close together, why not have them touch? And what we call the zero lot line and
Yeah.
maybe wind chimneys or something. It just seems that you're going to have some maybe privacy concerns if the window's open to get the air to go through. It also means acoustically, you'll be able to hear what's going on in your neighbor's house. Did you think about that, or?
Yes, I agree. So the reason why I separated them was because of the 3D printing constraints. At first, I thought of joining them, but the constraint didn't allow for it. But I think as the technology furthers along, it has the possibility of kind of joining those unit blocks and creating more dense unit blocks.
Okay. And you mentioned the difference between a regular, we're going to call it stick construction, and this construction as far as operation. What's included when you look at the data to tell how one is better than other?
I used a software to analyze the sustainability aspect, and it compared the units kind of like with the R values and the solar panel production, and it has the standard of a typical stick built, and it compared it to what was being designed.
Okay, so your comparison was really mechanical, electrical, plumbing, those things.
Correct.
Okay, thanks.
Thanks. Yeah, I was wondering also, sort of being like a module, why it couldn't be connected, because you're not going to get, like, you have this light pouring in on that middle rendering, but you're not really, you're not going to have that for all the internal homes, right? Did you think about the light for those internal units?
Yeah, so all the units were originally designed for them to be joined. So a lot of the majority of the light is already coming from the top and like bottom of the unit, or the north and south. So that extra 4 foot is kind of like extra daylighting or ventilation that's going through the units.
Okay. It would be good to see also on the interior some lighting, you know, whether it's ceiling lighting or some kind of lighting for non-natural lighting. But my actual question that I wanted to get to was just a little bit about your design concept and how obviously there's the mechanics of the printing and the curve, and I've seen, you know, videos and such, and that obviously influenced the form, right, with the curved edges. But talk about you know, the design, the facade design, and also like the interior, you know, is very linear. How does that connect with the exterior, which is, you know, has those curves?
Yeah, so I wanted to kind of minimize the kind of roughness of the concrete by adding wooden elements to kind of soften the space. Same with the interior. I wanted to add kind of like a more neutral, kind of toned material palette. I'm not sure if that addressed your question.
Yeah, I mean, I think, you know, it's a very interesting project and very thorough. Yeah, I was just more curious about the connection between the exterior and the interiors in the design vocabulary, where it looks very linear. Not that every interior wall has to be curved, but maybe there's some connection with the public spaces or the more important spaces to have that connection, maybe in the railing or other details, to just kind of bring the exterior and the interior into a cohesive design.
I tried to connect kind of like the railing from the interior to the exterior to kind of give the space, kind of the connection between the exterior and the interior, and also creating that double height space in 2 of the units that kind of helps bring more natural light and connection between the upper floors and the lower floors.
Okay, great.
Really nice presentation. Congratulations.
Thank you.
I think that maybe also for your presentation, just including some context, because I'm sure you visited the site, right? And so being able to add that, because some of your images feel like they're a little bit in isolation, right? So just having that and trying to see and understand those buildings, let's say, for instance, behind your buildings, you know, it looks like some of your openings are responding to those buildings behind there. Did you think about how that they might sort of mesh or talk to each other?
Yeah, so if you can see on some of the buildings, the reason why in the building block that smaller outdoor community space is set back is so that it starts to interact with those other buildings and becomes a space that can be used also for the units located behind.
Okay. and maybe just some process work to show us that. I also would love to see your thoughts about or the iterations that you went through to create these different volumes. I understand that there are these limitations that you're talking about, and understanding that maybe on the exterior there are these visual cues that help us to understand these differentiations. Because right now, if I had to just look really carefully at the differences between them, I wouldn't be able to tell. And maybe it might be use of materials or some sort of suggestion about how the interior is used or how many people can actually sit in them. Right now, they feel a little bit too homogenous, and maybe just a little bit of enabling people to make them feel different. Like that's my unit versus which unit is it? Does that make sense?
Yes.
But overall, really nice job.
Thank you.
Thank you for your presentation. One of the things I'm curious about is sort of your metrics and how you determined your site plan and sort of the scale of the project overall. Did you specifically look at the sort of housing burden within the city of Greenbelt?
Yes, I did.
What's like the unit count that the burden is?
Oh, I can't remember it exactly, but I compared the four cities: College Park, Washington D.C., and Greenbelt. And Greenbelt had the second highest in being cost burden. So that was one of the reasons why I chose Greenbelt. I wanted to also kind of create spaces of growth to kind of help aid people who are suffering being cost burdened. So as I worked on choosing a site, I saw that Greenbelt is growing significantly, especially new development coming in and having more residential units would be a benefit for its users.
Yeah. Well, one thing I was just thinking about is it doesn't really feel that dense. And I know that some of these are stacked units. And so, but I'm looking at the site plan, and especially in the sort of southern end of it, you have a bunch of blocks that only have housing aligning one edge of the block. And so I think thinking a little bit more about how you could really not necessarily radically densify the area, but add more density to really respond to the cost burden. Because I just think it's important to have a good sense of that. I mean, also just understanding how many residents you're being able to accommodate on the site, I think would be helpful. You also mentioned something about affordable home ownership, which is a really difficult model to financially model or performa. And so a lot of times when people are doing affordable housing development, it's affordable renter. And so I do think from like a cost perspective, I'm interested. I wish like, I know you're not a real estate student, but I would love to see sort of like how you actually would financially model it in full, because the units are quite large. I understand the cost of construction is a lot reduced, but maybe this is a way to move forward with affordable home ownership as a model, which again is very, very difficult to pen. That's more of a mega.
Thank you for your presentation and thank you for the models. Very good presentation. I like very much. Also, I like the technology that you study. Thanks to your presentation, we can learn about a lot of positive aspect about this way to build. So my question is, just because you find so deeper and deeper this technology, can you never think about some negative aspect, or if there is some criticize that from you?
Some negative aspects. I think the spacing requirements, like the level constraints, being able to use this technology maybe to even create multifamily developments could kind of further the construction process. Another, there, I don't think there is another one, but some benefits would be that it kind of reduces kind of labor safety, not safety. It reduces the risk of laborers being injured, so it actually helps decrease that risk. But there isn't too much currently since it's a new technology.
Thank you.
Yes, thank you for your presentation. I like how you went from general, the urban aspect, down to the wall detail and the structure. I appreciated that a lot. So one of the things that, just to pick up on what you just said, but I was thinking about it as you were going through your presentation. It is a new technology, so the time-saving aspect and therefore the economical advantage of these structures is also based on the fact that we need people that know how to construct them and fit them, right? Retrofit them after they've been printed. How far along are we in that process?
We're pretty far along. It even this construction process, even like if people feared that like workers would be like eliminating jobs, this would also be generating more jobs because it would need more people to be specialized in using the technology. And even statistically, it's showing that 3D printing construction is going to probably increase by like 50% over the next like 5 years. So it's already starting to come along in the area. In Virginia, there's currently a development of 200 affordable homes. And even Maryland government legislation is already approving to continue the development of 3D printing construction.
Thank you.
Thank you. Nice presentation. I have a number of questions. I do agree with the space between the units, and as you've made them curvilinear, they become more object-like, and therefore seemingly want to be spread apart. And if you knew that technology wouldn't allow them to share a party wall, which from an economical perspective, you've got two walls built adjacent to one another as opposed to them sharing, you know, seemingly like to take advantage of that. That obviously would decrease density, but I do think it's either just unnaturally too close. And therefore, you know, if the technology wouldn't allow it, the resultant of doing it and taking advantage of them being more object-like. And I think that's a, you know, it's a balancing act. I do have some questions about like what's front and what's back and how you place specific rooms in those different locations. What's different between what's at ground versus what's up as it relates to engaging the exterior, and then how that works relative to the site plan. You know, there's a kind of, I think one drawing missing here of taking kind of one block or a small block and understanding the landscape and how you feel these units relative to their context at a much smaller condition. And then the third issue is they're all different orientations. And how do these kind of modular things, which can be there, how do you adapt them to their different orientations as it relates to solar condition? Like if I look at the plan, all of the windows, you know, they're just kind of windows placed, but they don't necessarily reflect public-private orientation. You've got some porches which can be shading, but it's all vertical shading, but the different orientation. So I'm sorry, I have a lot of questions there, but if you can respond on some of that, I appreciate it.
So the first question of like connecting what's front and what's back. So the front is more public spaces, and I wanted to kind of create like a front porch that was kind of similar to kind of single family homes. So there's a few overhangs on some of them that kind of get the feel of like reconnecting with the community. And then in the inside, it's mostly kind of more public spaces of the ground floor of each unit. And then towards the back is a more public space, but each unit has its own kind of like backyard, which is located behind. And then the public would only be able to access at that kind of break, that larger break between the units. And the second question, I think it was regards to sunlight.
Yeah, in other words, in terms of sustainability and being able to use these in different orientations, how could these, begin to change as it relates to their different orientations in different places on the block?
Yes, I agree. I think each orientation would need kind of like another kind of like a sub-unit type that would kind of allow for different ventilation and light. But I think overall, the majority of them are responding to the ventilation and the natural light.
So just in the whole sort of public-private thing, and you talked about access to backyards and the like, and where is the line of the ground floor in terms of private versus the public domain? And then you've got trash and all the kind of practical things that need to be out there. I think that layer of understanding how these sit, I think, is what makes neighborhoods either successful or not, right? And I think that's just, it's one thing that I know you did a lot of work here. I recognize that it's a lot to cover, but I think it would have been one thing that would have given a layer of understanding of, the notion of creating community. I do have one question, like the sense over the magnitude of the site. How did you decide that, and what? And could you sort of discuss the phase 1 and phase 2 and why that's important?
I broke up the phase to kind of the first phase would kind of start with kind of like co-housing and duplexes, and the third block is mostly stacked duplexes. I think there's more development towards the top of the site and more kind of movement. So it kind of made more sense to start developing in that area. And then as to kind of reduce stress put on residents, as the development would kind of increase, it would start going towards the south of the site.
What in the printing process complicates the idea of having a shared wall between units?
So for the printer to actually be set up, there is this like 4 foot by 4 foot foundation of where the scaffolding is placed. So that is what's not allowing that connection between the units. So
Yeah, but that foundation could be left buried on, you need a foundation wall anyway, right? Footing, foundation. Yeah, so why, I don't understand why
so
it
it
couldn't
would,
work.
so once that building would be done, it would still require that space for creating the next building. So it would still leave that 4 foot space for creating the next unit, like kind of like next to it's existing.
Okay, well, I think there's a way around that. I think, because this would have been a much, let's say, more sustainable project if you didn't have to have two exterior walls 4 feet apart, where there could have just been the one wall. And so the construction of that other wall is taken away from the cost of the project. Basically, the way row houses are built. So, well, that too. Yeah, that was a whole another issue. So that's just my question. There must be a way.
I think
to do that.
I think as the technology starts to like increase the printing capabilities, it will be able to kind of maybe print 2 to 3 units at a time. So that could kind of help mitigate that aspect.
Right. Okay.
Just, I'm looking at that car. You're lucky if you get that one parking spot. But where does everybody else park if you don't have the unit with a garage?
Um,
Is
there,
there-
There would be street parking along the edge. Right now, currently, there is kind of an extra lane, so it allows for that street parking.
So there would be street parking along that
Yes.
double?
correct.
Okay, because I wasn't sure if there's like public transport.
And there's that along the main road, there's bus stops along the way, so there's kind of 3D printed seating areas to allow for the bus stops.
Really great presentation. I can tell you focused a lot on the architecture and the 3D printing aspects, and it looks like a real resolved project there. I think, not to harp on the the 4 foot, 5 foot separation between the buildings, but I think you should also look into, and this maybe is a little too real, but like fire separation there as well. You've got pretty big openings that are facing each other. So looking at just, how to maintain this curved sort of perimeter, but bringing them, having that party wall just be the single wall between the units, I think would bring it to another level, because I really do like the sort of Art Deco curves, and the even just like the tones are really quite beautiful as a standalone. I think you can kind of drop them into different contexts, and they'll work really nicely, I think. One question: have you thought about rainwater?
Yes, I thought of it a little bit, but I I was thinking most of the site towards the west is kind of flat, so a lot of the rainwater kind of doesn't stop there. There is a rainwater collection already existing right in front of the park, and another one up north. So most of the water already is being collected through there. But maybe in another iteration of this, there could be a kind of system that collects rainwater and is used on site.
Yeah, it looks like with a lot of the roof area, you could do some sort of variations with green roof and solar and some sort of water collection there at the roof surface. But also, I'm looking at the one rendering where the street looks really wide, and I feel like the next level of developing a community is really the kind of urban design aspect. And so, if you have that space there, I would really look into how that can be landscaped and be integrated into the architecture, as well as create the connections between the green space across. With the park, it looks like a really good opportunity. You've got a lot of width there that could be looked at. Yeah, I'm not as familiar with the context. It's probably suburban and very vehicle dependent. It looks very residential. So you probably want to consider multimodal uses just there at that street. So yeah, like looking at that rendering there, I think you can really illustrate the community that you're aiming to design. And the other question is, did you consider sort of playing with the block layout, or sort of pushing and pulling on the actual like perimeter of the lots, or you really like kept it constrained?
I played a little bit. So at first, there was actually a wider space between each unit instead of the 4 feet, where it was trying to create kind of like a community space but then that idea kind of got lost by it kind of started to get close to the problem of historic district with the privacy concerns. So I kind of went back to this block that kind of constrained that privacy issue.
The project that I keep thinking about looking at this, and I'm really glad you're taking on the problem of mass production in housing. because we struggle with that, and a lot of suburban housing actually is mass produced, designed to look custom actually, but it's actually mass produced. And I learned that one day when I was working as a community architect, and the house that was going up next arrived on a truck, and all the trusses were pre-made and things, and it was just guys with nail guns out there assembling it. It wasn't any kind of, and I guess this is the next evolution of that. I share the concerns about the snugness of the houses to one another. And I think one of the things that probably is true in a community like this is, sort of outdoor space for a house would be really important. And if some of the houses maybe were side yard entries where you came up the side yard and entered, it would have solved maybe some of the problems of the proximity issues. But the project I keep thinking about and looking at this is Corbu's project outside Bordeaux, France, when he tried to do mass production there, and the community, after living there for 5 or 10 years, started putting flower boxes on the outside of the houses, and somebody asked Corbu famously, Mr. Architect, what's they're altering the houses, they're customizing them, and things like that, and he said, life is always right. We architects must learn from that. Which was, I think, sort of an interesting commentary on how people customize things. So maybe that would be something you'd think about as you move forward in this. And I think the comments that have been made about the orientation and how you might adapt things to different orientations and stuff make sense to me. I think the areas where I have the most concern are where the units back up to those long slab buildings there. They look very, very close there, and the privacy issues are really exacerbated there, I think. I do think the taxonomy of the type, one of the things about this is for it to be successful, it both has to be, Leon Creer said once, in America, quantity is quality. In other words, if you can do a lot of something, it has great value in the marketplace, and production housing that gets done in America certainly shows us that, because they set up and do 50 houses, and bang, nobody bats an eye. You would want to really show how you make both the repetitive thing and make slight modifications. I think you've done that with the unit types, but perhaps where one could, I think a party wall would be useful if you could figure out that technology there, but where maybe they customize or differentiate themselves a little bit, so some of them look a little different than others as you go along, even though you set up to make them all the same, but you can make slight modifications to how they look and meet the street and things. I think if you thought about it again, you probably wouldn't want that garage right up on the street like that. You'd maybe there are interesting house types from before World War I, too, where that kind of house gets, even though there's no alley and you have to put the garage up front, it gets pushed back, right? So it's not so much a part of the public realm and dominating the streetscape as that image of it tends to do. But I applaud the effort to try and understand the relationship between 3D printing and also affordable housing. It's coming, I think as the technology starts to come and the ability to do these things becomes easier and cheaper, actually, I think we're going to see more of this.
I applaud you looking at this as well. I like the image on the upper right, that perspective where people are pausing and taking in the spectacle of housing being printed, right? And that really curious apparatus that's, that we don't see on construction sites that allows for the printing itself. My thought is about the how that apparatus can still register in the landscape and in the building beyond its use. Because I look at the animation and I see there's a moment here where the apparatus has done its thing and now it's gone, right? Its foundations, the cranes themselves, the printing thing, it's just gone, right? And it makes me think of a totally different building, which is by Stephen Hall, the Chapel of St. Ignatius, right? Where he was working with another type of rapid concrete construction. He was looking at tilt-up slab, right? And the genius of that project is he's taking technology that's typically used to build warehouses and he's bringing it to a sacred space. And what he did there was he asked for the concrete to be cast in the ground and then tilted up into place. But the buckles that allow for the slab to be pulled up then are adorned with these copper covers, right? And so he makes something amazing from the utility of how this really banal tilt-up slab concrete construction happens. And so it makes me think, makes me wonder, like how can maybe the foundations for this apparatus stay in the ground and register and maybe even participate in shaping the landscape, right? Because right now the space, like if I look at the perspective to the left of the one where it's being constructed, it's a little banal, right? It's just kind of open space. There's some seating. There's an outdoor shed. But what if the array of foundations for the printing apparatus becomes the foundation for the seating for a new arbor or shading device or something, right? So that again, so that the method of construction registers beyond just the moment of construction.
Eileen, thank you. I appreciate your bold vision here and also the clarity of your presentation. And I think that we haven't really talked about the social program very much. So I just wanted to talk about a few things. One is the question of maintenance of the common spaces. I think that, you know, there has to be some sort of organization taking care of that because you're proposing a very different set of living models from what we typically find in suburban places. The next thing is about the types of living spaces. And, you know, the co-housing is a pretty bold and different move. I'm having just a tiny bit of trouble understanding it as an affordable type because it seems to me that there's an awful lot of square footage there. And I think, you know, as I'm sure that you'll pursue, you know, this work as you go through your career, I think it would be very important as you go forward to probably do the real estate analysis and compare the sizes of these units with market rate housing and with other affordable housing. I think we haven't quite seen that analysis. You have convinced me that you've gotten the construction time frame down for sure. Not in building, square footage really, you know, leads to cost. So if we could understand whether these units are appropriately sized, I think that would be important. And you know, I'm just curious, you know, who lives in the co-housing, you know, and how long do they live there, and you know, is this long term, short term? And let me see. I guess just one more question. Just seeing one garage is funny to me because it seems like you haven't quite taken an attitude about the place of the car in this place. So, you know, had you had another semester, it would be nice to see what the public transit options are. And, you know, to echo something that's been said before, it really would be great to see the design of the streetscape. You know, yes, there'll be on-street parking, but how can you mitigate the bad climate effects of all that asphalt? How can you make it sustainable parking? And how many cars do these units have? What's your social vision? Lots of good hints here, but you know, so much more to explore in your career.
Okay, thank you all. And Marcus on Zoom, are you there?
Right there.
Okay, you have the last word here.
Thank you, Elaine, for a really great conversation this morning. I think a lot of the comments that you received and questions you received are reflective of the tension that was inherent in your proposition from the very beginning, which is you know, community neighborhood design versus understanding technology versus also trying to tie it to a specific place. But I think Professor Bell's comments were very apt that, you know, this technology is coming. it is kind of the next generation or the next thing that's happening. And I think applying that to the very important question of affordable affordable housing is a great way to invest your time, your energy. And, I've had the pleasure of seeing the evolution of this thesis, and, every suggestion that was made, I know you explored those, from it being, long, true row homes with party walls, to being further separated, to being, where we landed, where you're here right now. And I think, this is one of those things where perhaps over time, as these things get tested and lived in, we'll see further modifications and iterations on the proposition. But I think this was a great conversation starter. This was a great way to get us thinking about this. So I applaud your effort. I think the clarity of the drawings, the clarity of the presentation was very strong. And it's been a joy to work with you this semester. So thank you very much.
Okay, everybody, we are going to now turn 90 degrees clockwise and face the wall that's in back of me. And we'll do the next thesis student in just a moment. The sun might be too bright. The sun is brighter than this. Okay, that's good. So, good morning again. We have an additional juror joining us, and perhaps even one after that, joining us that we'd like to have introduce herself.
Hi, everyone. Mika Yamaguchi with ZGF Architects. I biked here today, so I was a little delayed. It's Bike to Work Week. So yeah, very interested in urban design, multimodal transit. You'll hear probably that aspect from me. All right.
And thank you all for joining us. We are, by magic of EVTOL, about to be transported through the air to Baltimore. Jose's thesis chair was Jamie Tillman. The committee was myself and Brittany Williams. You are now clear for takeoff on pad 5.
Thank you. Seatbelts? I'm glad to hear that you biked. I'll talk a little bit about that after. But hi, everyone. My name is Jose Gomez. And I am presenting Rethinking Movement. Before I do present, I do want to give thanks to Professor Kelly and Professor Tillman for helping me throughout this process in taking this concept that doesn't exist into something that could potentially exist actually in the very near future. So yeah, my name is Jose Gomez, and I'm presenting Rethinking Movement. in today's world, there's a lot of transportation problems. So many to be able to list in one thesis presentation itself, but just a couple that are really important. Today, transportation amounts for over 28% of total carbon emissions across various sectors. We've seen since 2020, but even since before that, an increasing rise in pedestrian accidents, either at crosswalks or automotive accidents as well. Actually, the statistics specifically for that from 2011 to 2021, I believe is the most recent, is over 70,000 accidents that are specifically pedestrian related at crossings. And another major issue with the transportation industry realm at the moment is this push into the existing landscape. We're constantly seeing expanding highways, roads that are constantly being taking up natural landscape. And so these are things that are not necessarily the best for the world that we're currently living in. More recently, one of the major issues that we've seen in the transportation realm is the recent collapse of the Francis Scott Key Bridge. It has shown that current transportation networks are rather fragile, and they affect not just the infrastructure itself, as in the case of the Key Bridge, but multiple sectors that depend on transportation to be able to move goods and people. I myself and many, some of you might even have experienced this yourself, specifically during rush hours. You will find anywhere from 15 to 45 or more minutes added into your commute times if you're traveling through the tunnels along I-95. And so this recent accident has really shown that another layer or another eye needs to be taken into account when looking at the transportation realm. So what if we start to change the way that we're looking at transportation? Today, there's a variety of new technologies that are starting to pop up that are starting to incorporate themselves into our current transportation networks. Some of those include electric power. Multiple vehicles are starting to incorporate electric batteries as the main source for energy to move the vehicle instead of traditional fossil fuels. Aerial flight is one of the booming sectors in the world right now, where we're starting to see drones and eVTOLs, which stands for electric vertical takeoff and landing vehicles. Another term that you might have heard in the past is air taxis. It applies to those as well. And more recent as well are new autonomous systems. These systems that are designed to help automate these processes to take people from one place to another or goods from one place to another without the need of a person to actually move these vehicles. What if we take those technologies and incorporate it into a new mode that's faster to travel, that incorporates a brand new network and changes that experience? Traditionally, as we've mentioned, the transportation realm is flooded with carbon emissions. It has almost this negative view that you might even experience when you go to a typical gas station. Our current transportation networks are limited to ground-based for the majority of our day-to-day lives, that being highway use, smaller roads, and even rail as well. But if we take all of those items or all of those categories and change it a little bit to make our experience better, but not just the experience, our day-to-day lives better, it can create a new network that starts to incorporate this aerial technology and starts to populate new areas. And so the thesis question that I've been working with for this semester was, how can autonomous and electric transportation technology promote both wellness and safety through its integration on existing infrastructure? I mentioned that the eVTOLs, which are starting to appear nowadays, they're electric powered, and they can carry both people and goods in any place that they can land. The advantages of these vehicles are, one, being electric powered, they don't have carbon emissions, and two, because they are not restricted by the traditional transportation networks, those being ground-based on a two-dimensional plane. They can move faster, they can move more efficiently, and they can get to a place quicker, safer. These vehicles are starting to appear as we're speaking now. They're continuously being developed by multiple companies, and we will be seeing these in the near future. In fact, there's this program called Innovate 28 that's created by the Federal Aviation Administration, which is the sole company or organization that's regulating the development of eVTOLs and this concept known as advanced aerial mobility, which incorporates both these eVTOLs as well as smaller drones and the general landscape of aerial vehicles for the future. Their goal is to have these vehicles up and running at facilities by 2028. So these vehicles and this technology is coming. However, one of the things that they are missing at this point in time is an infrastructure to be able to accommodate them. In one way, as we have bus stations, or as a bus has a bus station, train has a train station, these eVTOLs need some kind of station to be able to operate, to be able to be maintained and to serve as multiple stops and start to populate this new network. And so that introduces the vertiport concept, which is this new infrastructure, which allows for a multimodal access point where one can transition from ground-based transportation into aerial-based transportation. Specifically, as you can see on the screen, there's multiple levels of these vertiports depending on the amount of vehicles that they will be able to handle. The way I see them, a vertihub, which is larger scale, is more like the station for the bus or the train, while a vertipad or a vertibase is more like the bus stop. And so once these types of buildings start to populate different cities, it creates this new interconnected network that allows for faster transportation from point A to point B. And so as we zoom into the site that I have selected for this project, we see that the vertiport, in a sense, isn't necessarily new. Rather, it's the evolution of the current heliport. Specific to this project, the site that I've selected is in Canton, Baltimore, specifically the industrial site. You can see this site as soon or right before you go into the tunnels. It's called the Pier 7 heliport, which can be accessed directly from I-95 as well as through the Chesapeake Bay. And this site currently serves as a heliport. The pier that extends out into the water can hold up to 7 helicopters for deployment. However, the entire area being an industrial site has very little public realm to it. Granted, it is for the industry to work. However, it's missing a little piece of public appeal to it. And so I present today the Baltimore Vertiport, which is a evolution of this existing heliport. The heliport is both a tech-focused hangar on one side with a collaborative tower on a site just across the street, and it is combined by this experiential spine that extends from the top of the tower down to the existing pier. The purpose of this project is to both preserve the pier, repurpose it. Instead of it being the mode for transportation, it now becomes a place for people. The vehicles move themselves onto the actual vertiport itself, and it starts to create this new vertical experience, not just in the actual movement of people through the vehicles, but in the actual building itself. So the ground floor, as I mentioned, consists of both the pier that extends onto the water, which has now been extended to accommodate various programs, a hangar, if we can get the laser, a hangar portion, which houses both a technical aspect of the project, that being the eVTOLs themselves. The hangar takes care of charging necessities, as well as on the upper floor, the actual landing and takeoff of these vehicles, and a tower that on the ground level is more focused on the the connection between vehicle to person entry. And so a couple of views to kind of describe this experience. As one drives into this area, the first thing you'll notice is the connection between the pier, which has a spine running through the hangar up towards the tower. The hangar itself, which accommodates the eVTOLs themselves, is, as I mentioned, focused on the technological aspect of the project, this being charging, loading and unloading of goods, and general maintenance for these vehicles. And out on the pier, that has now been transformed from a traditional helicopter landing spot. It's now become a place for people to gather and a place for people to start to incorporate multimodal aspects to it. So now you can use the pier not just for the traditional helicopters, but now it's to incorporate water-based travel. As we move a level up onto that experiential spine, we come to the areas where we'll have our boarding tunnels, highlighted in red over there, and this unique loft space up on the tower portion. The spine leads directly into the tunnels for the boarding of these vehicles themselves. And the idea here is to start to change kind of the experience of walking through a building. It starts to bring a little bit of the exterior into the interior with the addition of green walls and with the addition of glazing to kind of make you feel like you're outside. As you approach one of the actual eVTOLs, you can come in through these extendable canopies that come out almost over to the vehicle to help provide some cover depending on different weather conditions. And on that upper loft level, which has multiple floors, this is the loft level, which has a couple mezzanines up there. The upper portions of it are more for the publicity of these vehicles to help promote this technology and these vehicles. As we move up on the tower, we have another landing spot above that offers direct access to the other programs in the building, which are specifically different lounges as well as WeWork and office spaces to help make this a collaborative space. And the subsequent floors, or the typical floors, are also mainly focused on office spaces. So what this helps provide is this direct access from vehicle to work areas. One can, in a sense, experience this express mode of mobility to be able to get from one place to another place and be able to almost bypass the traditional waiting times of airports. At the top of this experiential tower is this almost 360 view that one gets of the city to help enforce that vertical experience that the tower provides and help connect you with the environment around. At the top, you can see the entirety of the Baltimore Harbor, as well as, not presented in this view, but the rear, which is a more industrial area. And so, to recap, the Baltimore Vertiport has this spine that serves kind of as the datum line for circulation, which extends from the pier up all the way into the tower. And in a sense, it brings the water all the way up to the sky. It's almost symbolic in bringing all of these modes of transportation and pushing them towards the future, which is of aerial mobility. For a couple different issues that come with the implementation of this technology is mitigating sound. And so to do that, the tower uses acoustic glass, while the hangar itself uses fiberglass panels to help mitigate sound. With the introduction of these vehicles, it's necessary to incorporate energy and shading devices to help with shading. This tower has shading fins to help with the sun shading overall. And for energy, I apologize, this is the incorrect diagram. I am pointing on the fourth board. Here we go. The entire spine is made of photovoltaic glass, which helps bring in energy to help charge these vehicles that they will be servicing. And the structure itself consists of various depths of columns. The tower itself is mostly made of beams, while the hangar is made up of multiple trusses to help carry the heavier loads that these vehicles bring on. And so to recap, this new vertiport creates a new node in Baltimore, which helps create a new network that can start to expand out into various areas. It can offer new connections to BWI to various cities around, and these vehicles themselves can start to create smaller networks at different scales. In essence, the Baltimore Vertiport starts to push this idea of a vertical experience, this multimodal form of travel, and this new node with multiple access points to both ground-based travel, water-based travel, and air travel. And that concludes my presentation. Thank you.
The critics are now cleared for an opportunity to talk, and I hold the implement of critique for whoever would like to use it. Make sure you do use it, though.
Sure. I just have a question about the vehicles. Are there any plans for bus-size vehicles? Because right now this is kind of private and 4 or 5 people, you know, to leverage this so that it makes sense financially.
Yeah, so I've done a lot of research on vehicles. I hate to admit it, sometimes even more than the architectural aspect. I really like this technology. Just looking at the industry and the development of the technology at the moment, it is brand new, so it's still smaller scale. From the vehicles that I have seen, I think one of them has a max of around 6, so it's starting to push a little bit more maybe to what a van would be like. The majority, though, are from 2 to 4 people, including or in addition to a pilot, so around 5 people, which would be equivalent to like a taxi driver and 4 other passengers. The technology is still a little bit newer, though.
I'm sure this costs a lot more than a taxi cab.
Yes, I meant more in terms of like people occupancy.
Yeah. No, but I'm just saying to get the return on investment. Sorry, getting real world stuff, but it just seems like this would be an incredible investment for like in New York, where they have the heliport, like you said. It's really for really rich people to get out to the Hamptons or wherever, and it's expensive. So I would just say maybe you've oversized it, you know, for the use for the limited number of people. I mean, the architecture is great. It's like now you have to go back and make sure they make a vehicle big enough to get the return on investment with the number of people to make it more democratic, if you will.
Gotcha.
Like a way a bus stop, you know, and the number of people that can take a bus versus, and that's why people take buses sometimes instead of taxis, because it's more economic. So I just think that's your next thing you should look at.
Coming down 95, I've always wondered what that brick tower was and why it was there. And now getting a better understanding of seeing this location, and certainly the notion of helicopters and the like and the noise that they generate, you know, suggests that perhaps, you know, center of city is an issue. But seemingly from an urban perspective and being able to get to downtown Baltimore, this seems pretty distended from that. And I'm struggling with the quantity of people that would ever come here to activate all the public space you have with this pier. And the pier being complicated as an outdoor space with the noise. where my office is in Philadelphia, Jefferson Hospital's there, and the heliport is on top of the building a block away. And whenever that helicopter comes, it's so noisy, everybody just stops. And, it's very, detrimental to public space use in that regard. And the second issue I have is architecturally, it seems like you lost an opportunity to take advantage of this new type of transportation. And I think back about the days of TWA and Saarinen and Dulles Airport and taking an architecture that would be evocative of this type of transportation. And seemingly the building looks like a general office building, as opposed to something that could be notably, emblematic of the type of transportation there is.
Yes, allora, thank you for your presentation, first of all. And then one consideration, because during your presentation, my memory was about 1 century ago, when, new technology arrived in the world. Think about the cars or theater movies. At that time, we need a new type of building. So it was interesting to me how the history is repeating with the new technology. We need a new type of the building for this. So if you think about 1 century ago, at that time in Europe, the style that was very popular was the Art Nouveau, the Liberty. So we have an incredible garage or theater movies that follow the style of Art Nouveau. So I wonder if in this case, we have a new technology, new function, you need a new typology. So I agree with the idea that it's still an office building and probably we need to develop other area. So think about also the architecture aspect, the architecture public face. The architecture is the public face of the building. That's my consideration. Thank you.
Thank you.
I have a question, actually. You mentioned that the panels, the glass panels, are photovoltaic, so they would cover most of the energy required for charging?
The photovoltaic panels would be that spine. I haven't done the actual calculations for the square footage to figure out how much charging. So I would have to research that to give you a precise answer.
So, okay, but I just wanted, all right, so then my question turns into a consideration at this point. So just the spine would be energy producing for your new transportation node. Very interesting, by the way, congratulations.
Thank you.
So the consideration that I have is, if we're using plug-in technology, this is plug-in technology, correct? We're using plug-in technology, it means that we're talking about something that is apparently clean energy, sustainable, because there's no carbon fossil involved. However, if the source of the energy is not sustainable energy, so if your photovoltaic panels are not sufficient to charge or to keep, the hub working autonomously, then you're relying on other sources of energy, which could be, in fact, carbon fossil-based. That's the problem with plug-in technology, right? Even if you have a plug-in car or electric induction, cooking stoves, tops. We need to know the source of the energy, otherwise we're just backtracking the problem. So if this, I think that my comment is, if it's self-sufficient, then the sustainability is a resolved issue. It's wonderful. But that's a big if, it really needs to be. So the square footage and also the amount of, VTOLs that you have parked and charging at the same time. And also maybe the energy that you need for the amphitheater, the recreational area. This is all very interesting because it's actually a used area, right? Even for people who maybe not accessing the eVTOLs.
Thank you.
Thank you. One of the things I'm thinking a lot about right now is just sort of the identification of this particular site. And I feel like you could have been a little bit more discerning in identifying a site that, maybe to your point, would help reduce sort of like carbon emissions. And so, and also to your point about it not being particularly accessible to people, like the average person. And so I'm wondering if there's a way to relocate this sort of activity closer to the downtown center, perhaps pairing it with other modes of public or mass transportation, whether it be a train or bus stations or something else, just so you're not pulling people so far outside of where places of employment or commercial activities are taking place. I'm looking at this office tower and one questioning the size of the tower relative to everything else in this landscape. I mean, there is one other tower nearby, but it just seems quite over densified relative to the existing industrial fabric. And then the idea of it using an office, which since the pandemic, I think we've kind of have to reevaluate Class A office space, especially since there's quite a lot of vacancy in that room. And so I'm just wondering if there could have been a little bit more of precision and just a way of making sort of symbiotic relationships between existing infrastructures and amenities, just to kind of warrant this much development. Because I feel like this would only be accessible for billionaires and like multimillionaires within the community, which Baltimore doesn't necessarily have a ton of. So I think finding ways to democratize access to this type of technology and really leveraging existing infrastructures would be helpful.
Yeah, one of the things that I looked at throughout the semester, I mentioned the analogy of kind of the bus station to the bus stop, and the advantage of these vehicles and this technology is that it doesn't necessarily need a lot of area to specifically land in various ports. This specific vertiport as a concept kind of stands as kind of the bus station in the sense that it's the larger hangar-based model where these vehicles can be both, what's the word, sorry, maintenanced, serviced, while still offering kind of this central area for people to come. But specifically towards talking about the network, as different areas begin to be populated with smaller vertihubs, I think I put a slide with like smaller spots. Those kind of become in example, the bus state or the bus stops where these vertiports can come in to pick up people at those areas or drop people off. And so these can start to become populated in various areas. I've done a bit of research in the different uses of current typologies for some of these, and the one that's most prominent is using existing parking garages. A lot of parking garages at the moment, the upper floors aren't really occupied. And so they're already structurally sound to be able to carry the loads of these vehicles. And so this is something that I've talked about throughout the semester. Maybe like a sub-project or an extension of this thesis project would be to start to develop some of these parking garages into new VTOL stations. Or sorry, not stations, stops for these vehicles to come in. And so what that would do is now we can start to populate the inner city with these stops where they might not necessarily be the best places for the larger scale maintenance of them.
Thank you for your presentation. This is really interesting to me. I find drones very sort of contentious in a lot of ways. I was also, I share a lot of the sort of thoughts and comments that were already shared about the location, just kind of creating that last connection to where people are coming from, I think is really critical for a hub, especially if you have public programming, which I think is really a big part of this project, and the sort of educational aspect for something that's being introduced to society. So I mean, I really like the amphitheater and the recreational area. It reminds me of the airport park by DCA, where people can just go to watch things fly. And It doesn't matter if you can afford it or not, but you can go and like sort of enjoy the public aspect until things become more accessible. So I think that's really neat. You just need to create that last connection to where people can easily get there. I understand that there is a concern about noise and probably flight path for a lot of this. So it is sort of a logistics challenge. So I understand why you'd choose a place that's a bit remote. But you'd need to kind of make the land part of the multimodal travel a little more prominent in the design. I was wondering, have you seen any video footage of the drone show?
I have not.
No? Okay, well, there's...
I will. I will.
You will? Okay. Well, there is some way that you can really choreograph these things so they can fly en masse. And it is kind of interesting to see that, because then you get the critical number. And I wonder if there's a technology that will, if these things are autonomous and can fly en masse together, that you can sort of simulate something that's more like a bus or a plane at some point, really dependent on the travel route, which will probably become very important. Just looking at these sort of hubs, like these things can essentially fly anywhere, but there are air paths that you want to take into consideration, right? Yeah. Otherwise, I think this is really cool.
Thank you. I had the opportunity to speak with a gentleman by the name of John Slaughter, who works with the, and Professor Tillman, you can correct me, it's the UAS, I believe. It's the kind of organization or program that's currently working in developing AAM technology. One of the comments he made was that because of the newness of this technology, it almost needs this push to really become something for people to really come out and see and experience these, to get people on or kind of grasp the technology. When it comes to the autonomous aspect of it, some of the research that I've done in the previous semester, there's kind of this negative view towards autonomous vehicles. Obviously, there's a lot of ethics regarding it. I'm not going to dive into that, but in order to kind of get people to kind of adopt the technology, one of the comments he made was it needs to really grasp the user and be something like a really special place. And that was kind of the idea with repurposing the pier to become a place where people can come out here into this area and kind of experience this. Just a quick little note on the multimodal aspect of this. The Baltimore, I forget the name, not the trolley, the boat that comes around. This spot could potentially serve as a new spot for that network there to come to this place as well. So it helps bring that connection from the inner harbor to this spot as well. It's not just through the ground-based, road-based network, but you can also come to this place by water.
Hello, thank you, Jose. This is really interesting, and we have so many jurors that there's so much has been said by the time it gets over here. But I do love the idea of the park. I think people love to gravitate towards water. You're seeing it in New York City. And I'm wondering about sort of the experience, because they're starting with, again, the scale of the building is very large, and it's a little bit, it's not as welcoming. What is that experience of them walking through? How do they even know there's something back there? And then when you get there, and it's probably wasn't the largest part of your project, but I think it's a bit static. In the recreational area, there's this huge water element, but there's water everywhere around. So it's not really necessary to have that there. And it perhaps could be a great place for a sculpture garden or incorporating local artists in Baltimore. The amphitheater is also quite large and static, and I imagine there would want to be some flexibility with smaller events. And if you're bringing everyone out there, there needs to be some sort of restroom facility because it is a bit isolated. And I think that, I want to hear a little bit more about that experience. I mean, there does seem to be, you talked about a green wall, and I'm not sure where that is. There does seem to be some greenery as you're walking through. But then once you get through and you're at that open, which I understand is the spine sort of opening up, it's looks like a pretty standard, like columns. Is there any, I wonder what your intent was for that experience? Was it to sort of to open up and, is there more now that you've kind of had a chance to look back that you could do to create that long experience? How many feet is that from end to end?
It's end to end being out on the pier or also including the building?
Yeah, if you're coming from land and you want to go to see something at the amphitheater.
I believe it's roughly 300 feet. Yeah, that would be 300 feet. Regarding your first comment about the program for the pier, one of the ideas that I had for that kind of recreational area there and having the kind of that enclosed water was obviously this technology is developing and it's not limited to just the aerial based mobility. We've seen with the recent events of the Key Bridge how we can also start to improve water-based travel. And so the idea with kind of having that enclosed water space is kind of like a testing ground for water-based drones, smaller boats that people can come in and test there, and at a kind of funner scale, if that's kind of an approach. I can imagine people coming here with their children, maybe they have their little toy boats and they want to use this space as that space to engage with the vertiport.
They can use those insets too, right? Because there is sort of that natural space in between, right, where they could do that also.
Yeah. They could. Those are a little bit more designed for boats to come into, so that there's this water connection, so people can use it as a pier or a deck, be able to come on to the building itself by water.
Yeah. It probably would need some shade as well. I can imagine sitting at the end of that at some event in the sun, just bouncing off all the water. But just going to your building for a moment, I think the concept's really strong with this slice and how it, it really clearly delineates through the site. When it gets to the building, talk to me about it's a very intentional split. Is something happening on one side that's not happening on the other side? I see that there's the loft space on the larger side, but then on the typical floors, it's really mirrored. Is that right?
So the north side, it's more office-like spaces, so a couple WeWork spaces and kind of more private enclosed spaces, while the south side is the more public, open, no walls, and that one's more focused on kind of this lounge experience. One of the reasons for that, obviously this vertiport, the original thinking of it was kind of a deviation or a derivative from kind of an airport-like program. And I imagine as the technology improves, these vehicles will become quicker, but people are still going to want to see and experience this technology. And so having those open spaces more towards the south so that they're actually aligned with the hangar pads itself kind of gives that visual connection with both the pier and the activity of the vehicles themselves.
Right. So the public spaces are the lighter blue. That's sort of delineating
Correct.
The lounges.
Yes.
Yeah. Because I was wondering the sort of the exterior fenestration, the design, where that came from. I get the slice through, but as far as the other parts of the tower, was there a design?
Yeah.
What drove that design with the verticals versus the horizontals?
Sure. So I looked a lot into projects that start to deal with some of this. One of the projects and kind of the general ideas that I got was from Norman Foster, that design style where it starts to push some of the programmatic elements out a little bit. And so some of these larger loft spaces, they start to protrude from the general core of the tower, as we can see in, sorry, I'm trying to find the laser. here we go. So this one obviously starts to protrude both out to create that loft space with that visual connection to the VTOLs, but as well as provide another VTOL landing up top. The second portion, if I can find the laser again. There we go. Yes, I can do that. I forgot I have legs. Yeah, so some of these spaces start to protrude a little bit out, both for also that visual connection down onto the space below, but also in some of these spaces, they can start to become larger event spaces or even be repurposed for the exhibition of some of these vehicles as well. I mentioned kind of this concept is having this vertical experience, and so bringing them higher up, having that sense of height in the city is really important for this project. And so having those pushes and pull to kind of delineate these spaces for overall views was important for me.
Yeah, I think maybe it could be pushed just a bit more to really add more dimension, and maybe there are outdoor spaces that give a more depth to the facade. I think that's what somebody mentioned, like it's looking a little, like an office park, just a very massive building. I think you really started with, the hierarchy of the spaces and shifting, but maybe just push that a little bit more to have a little bit more visual interest there.
Before
I like the idea of the space.
Sorry, before I do forget, also one of the kind of concepts of kind of pushing the building off to the side, when I originally thought of aerial technology for this, the thing that immediately came to my mind was aircraft carriers, and both the design, kind of the slopeness of the hangar, but as well as the pushing the tower almost to the side. It's a common trait, and so it's a little reminiscent of both the nautical experience of the aircraft carriers, and representing that in the building massing as a whole.
No, I do appreciate that it's not like sliced in the center.
So it's a really nice job. I'm glad I'm young enough to be able to maybe wait for this technology to actually occur.
2028.
That's what I'm saying. I can't believe it. I can get rid of my driver's license soon. So I really commend you on taking on such a massive scope. I think sometimes we get almost too ambitious, right? But it's better to just go for it, right? I think when I heard about your fascination with these technologies and these kinds of ways of transportation, it struck me that yes, you are really in love with these, which is fine, which is great, right? But I think what starts to get missed is sometimes the human experience, right? And so trying to toggle between these two massive scales, right? The one is like enormous, right? These machines that we don't really have spaces for per se, right? And then the human experience. And so it's really interesting that when you show these images, I feel almost overwhelmed, right, in these spaces. And so I wish you had just embraced that. Let me just design something that really hasn't been designed before properly, right? And that's what you're taking on. You're taking on a whole new building type that really doesn't exist. And I think capturing that imagination, I almost feel like you got a little bit bogged down with, I gotta make spaces to justify the verticality. Just make a tower, right? Just say the hell with people. I'm just gonna make a tower. You know what I'm saying, right? And diving deep into that, because I see something like the hangar interior, and I kind of see like the Death Star, right, in Star Wars, and something like that scale that we just are not used to. And then when I see the spine experience, I see something like just doesn't feel like I want to be there, right? So I guess what I'm saying is, focus more on this brand new kind of place that we've never heard or seen before. And it's for this new place. You want to capture the imagination that these beautiful, somebody mentioned TWA airport, and even our own BWI. Though, I'm sorry, not BWI, Dulles, right? Those are the spaces that really capture the spirit and imagination. And so I think that's where I would have loved to have seen you go, is let's see this new project that we've never seen before for these machines that we're not even familiar with. Like, take us into the future. And so I'm sure at one point you're maybe split between like, okay, I have to do this, but then I have to do that too. So whenever you have to sort of bifurcate your desires, it's sometimes, things.
Yeah, it was definitely hard kind of balancing that. Is it real, or is this off into Star Wars movie, So it was a constant battle. We've had discussions about that.
But I appreciate the leap forward into something really new.
Matt Bell, you're going to have the last word. Wait for you. You have to have the microphone. No, you need the microphone
Thank you.
because people at home cannot hear you
No,
without a mic.
Thank you, Professor Kelly. I
voiceover.
obviously was totally unaware of that previously. This is a very complete proposal, Jose, and congratulations to you for bringing it this far. A couple of thoughts. One is, someone made the point earlier that it only carries a handful of people, right? And if you think about the history of flying, it started off as a very elite thing. If you look at the 1950s and 30s and stuff where people were flying, it was a big deal. And then, with deregulation, a lot of other things happening, it became quite popular and airports expanded and became ubiquitous and things like that. Everyone could afford it to some degree and stuff. So I think the comments that have been made about maybe this being something, imagining it as something that becomes much more every day is sort of interesting to think about. Because then one might think about, well, what do I do? You mentioned putting things on parking garages and stuff downtown. It would be important, it seems to me, to figure out what is the icon of this mode of travel, So for example, when people show the picture of the Washington metro system, those vaulted, sort of forms, everybody knows that's DC, or Moscow or St. Petersburg and their metro systems and things like that. They have a very tangible kind of experience for the traveler in terms of the forms of these things. Or even Nervi's hangars that he did, in the early days of military airplanes and things like that in Italy were quite distinctive and quite innovative technologically. And I think probably something like that might be in order here. The other thing that I find a little bit curious about this is when I look at the actual urban design and I think about the pier and the tower and all the different things going on in there, the sort of business of this kind of flight going on there seems almost incidental. And that might be a good thing at one level. It might be good that it's sort of something that's part of a larger idea. On the other hand, one would wonder, well, should it be something more, sort of more spectacular, something more, at least as a first thing out of the box, should it have more retinal burn? You look at it and you think, well, there's the iconography of this project is that building, like Dulles, like TWA and other airports that have been cited. So that would be another thing you might want to think about. If you took the idea of the retinal burn of something that was very powerful iconographically and said, okay, that's going to spawn a bunch of children, and they're going to be around the city. I'm not sure I'm ready for small groups of people flying around in these things, a la the Jetsons. I'm probably not going to do that myself for a variety of reasons, but it could happen. It could get to that point, in which case you would want to sort of have perhaps an idea about how this thing, unless it's like the New York City subway, which starts off as all these different companies, right, and somehow gets unified at some point in time. Do you start with something that's more unified as a way of looking at it and experiencing it, and what are the architectural propositions? Because if you take away the pictures of the flying thing there, it's kind of like an interesting mixed-use development with a very important waterfront component, and the flying stuff seems kind of almost incidental to me. It doesn't seem like it's something that is born. The thing is born for. And by the way, you should add water airplanes that land on water. There.
Great, thank you, Professor Bell. So I'm the chair. I get to say a couple of things to Jose, and the choreography is important. So I'm going to come over here and pivot and address you like this. I commend you for taking this on, and this began with your participation in the Aerotropolis studio 2 years ago. It may have started before then, I don't know, but your enthusiasm and embracing these new ideas and new technologies is really commendable. So, a lot of questions. So I would say embrace everyone, because this technology is coming. As you mentioned, the FAA is certifying vehicles now, and eVTOLs will be coming to urban areas very, very soon. there are always things in reviews that kind of come at you from different directions that you hadn't anticipated. There was a comment about the sort of the drones and the ability to do displays from drones. Actually, this site, the helicopter capability here is based a lot on tourism right now. So that is the primary commercial use of this site. But finally, the one thing that I was very heartened by was the discussion of architecture. And so I'm a fan of Giacomo Balla and Umberto Boccioni and the futurists. And if you think about Sant'Elia's famous drawings of the integration of different modes of transportation, they are, to me, and I hadn't thought about this before, a little bit reminiscent of your interest in integrating these modes. I do think you're successfully bringing the public into this conversation. And as the technology gets more efficient, I think some of the social and commercial issues will begin to fall into a useful category. So I want to congratulate you on embracing this, and I look forward to your trajectory moving forward. So congratulations.
You can take your seatbelts off now. We've moved into the gate. You can get up and move around for a couple seconds. We have to reposition these panels so that the next student can present. And if we could get some help from the press corps over there, the thesis press corps, to assist your colleague to do that, that would be greatly appreciated.
We want the best one.
Wednesday, I guess. Okay, let us gather to restart for the third of 3 morning presentations. If you can hear this, gather over here. Okay. Hello?
Hello, everyone. My name is Abdullah Hussein, and this is my thesis, Inhabituals. Okay, and hello, everyone. My name is Abdullah Hussein, and this is my thesis, Inhabitual Assembly. The thesis looks into how we can utilize prefabricated wood construction assemblies to provide sustainable homes across the United States. It seeks to take advantage of timber as a building material in combination with subtractive manufacturing to produce sustainable assemblies that have minimal impact on the environment. Timber is an advantageous material as carbon stocks have been increasing within the United States, and it holds great sustainable qualities like carbon sequestration. And when combined with subtractive manufacturing, it has a great deal of capabilities. Much of this exploration is in response to conventional methods, which are not robust when it comes to sustainability and are heavily reliant upon synthetic materials. For example, the use of polyester foam insulation, as well as polyethylene vapor barriers, as well as the use of synthetic sealants and adhesives for plywood sheathing. All of this together have adverse effects on the environment. One of the important aspects of this exploration is evidently the CNC machine. And for the CNC machine, one of its important parameters is the bed sizing. The bed sizing can vary from machine to machine, but generally speaking, it usually is 4 by 8 feet. And the depth itself can vary quite a bit, but is generally around 8 to 10 inches. Another important parameter is the machining parameters, which is defined by the speed and the feed rate. The speed is the rate at which it moves in the X and Y direction, and the feed rate is the rate at which it drills into the material. These are important to mention as linear cuts, both in the X and Y direction, are the most efficient alongside alongside the machine drilling into the machine vertically. One of the great benefits of using this technology with timber is the ability to standardize some of the essential construction elements, which leads to high volume production. Prefabrication in general is quite efficient in terms of time. It takes about 30% of conventional construction time. It also provides us the opportunity to integrate complex custom joints. This allows us to create structures that are usually reserved for concrete and steel, which are energy intensive, and makes timber a viable alternative. Another advantage of this technology is the integration of all wood joinery. There was a study done in Hamburg, Germany, where they found that they were able to reduce thermal conductance by 30% by integrating all wood joinery. And so it provides great opportunities for improving air tightness. It also provides the opportunity to use wood that has been damaged, the ability to replace fire and beetle damage as well. And one of the important advantages to this technology is the ability to integrate wood connectors, where we can use high friction openings to integrate wood connectors such as dowels and screws, and minimize, in some cases, eliminate the need for synthetic sealants and adhesives. Similarly, we can use lamella profiles, where we take strips of wood, inexpensive strips of wood, and use precision joints to put them together to make robust assemblies. In terms of where this thesis lands in this conversation, it's mainly focused on taking the advantage of using wood connectors as well as lamella profiles to create sustainable assemblies. The project is siteless, and its main parameter is working within climate zone 4 and adhering to different requirements, including the R values. Another element that contextualizes this project is the material, which is loblolly pine. In terms of sustainable harvesting within Southeast United States, it's the one that is readily available to us. And additionally, it has great qualities. Pine alongside spruce and cedar was rated as one of the most airtight species by the Department of Energy. And one of its great advantages, for instance, is for each inch of this material, it has an R value of around 1.4. So it is quite advantageous when it comes to the assemblies. When we come into the design is made up of, the wall panels are made up of cross-stacked Dow laminated timber. As I mentioned earlier, the bed sizing plays an important role in terms of these panel sizes. Each of these are around 4 by 8, similar to the CNC bed size. For the exterior load-bearing walls, I use 5-ply cross-stacked Dow laminated timber, and then for the interior partition walls, I use single-stacked Dow laminated timber with 2 by 6 horizontal bracing. In terms of the assembly, the loblolly pine are made up of 2 by 4 pieces of wood, in which the CNC cuts openings equidistant from each other. And these openings are fitted with 3/4 of an inch hardwood dowels, which have a different expansion rate than the softwood, which is the pine. These openings are actually 0.74 inches instead of 0.75. These allow for a very tight fit to the assembly and minimize the need for synthetic adhesives. An important factor to all of this is the weight of these panels. Depending on the typology we're working with or transportation needs, we can utilize these smaller sizes. So we can use a 2 by 8, a 4 by 4, as well as a 2 by 4. These would merely require more connections, but still would be as effective as the 4 by 8 panel. An essential component to these panels is the connectors, which are essential to the assembly. There was a study done by the organization Woodworks alongside the U.S. Department of Agriculture, where they looked at different connections, to panel-to-panel connections. The 3 that I came upon, again using 2 by 4 profiles, were the double spline joint, as well as the single spline joint. The double spline is basically 2 profiles that have splines on both ends. The inverse for the single spline is that the grooves are alongside the interior, and then there's a spline fitted through the profile. And then for the tongue and groove, one side has a groove and the other has a tongue that is fitted into it. To test the merit of each of these joints, I isolated each of them and cut them via the CNC and conducted 3 researchers making tests. One of these tests was the moisture test, in which each of these profiles were submerged in water for 24 hours. There's also the compression test, in which they were subjected to 10 consecutive hits with a 64-ounce mallet to see where the loads were being distributed, as well as the bending and racking test, where they had original stress applied to them to see how they react to lateral forces and where the weak points are, where they break. For the moisture test, they were submerged in water, as mentioned, for 24 hours, and the volume was mentioned before and after. For the double spline, it performed the worst, and with a 4.86% increase. The single spline with a 3.67, and the tongue and groove with a 3.57. So the 2 performed quite well. When we would move to the compression tests, so basically subjecting them to the mallet and seeing where the force was being distributed to see where the force would be going. And this is very essential in terms of understanding how effective it is to the overall assembly. So as we see, instead of the forces being distributed to the mass timber walls, which are more robust, they're being subjected to the profiles themselves, which are far weaker and don't have the ability to handle that much force. When we move towards the single spline, the same test where they're just being hit by the mallet, a 64-ounce mallet, and we see that it starts to come apart. But this is actually quite advantageous as we look at where these forces are going. Instead of going outward, they're going into the mass timber wall, which will take up much of the load instead of subjecting each of these profiles to the compressive forces. The tongue and groove performed similarly, in fact, better. It held out longer than the single spline, and similarly, the forces were being distributed towards the mass timber walls. And so, as I mentioned earlier, similar to the single spline, but more effective. And this is the bending and racking test. This is for the double spline. So the weak points you see are the points nearest to me there. And as I subject more power, more force to them, those 2 points at the end over here start to give out. And they held out quite well compared to the rest, but once those points yielded, they yielded quite instantaneously. So it had 2 weak points, 2 primary weak points over here and 2 secondary ones over here, but it was quite robust. This is the single spline subjected to the same tests. We see that these 2 corners, the cracks start to emerge pretty early on, but they held out together quite well for a while. And this is important to note, as we'll see with the tongue and groove. But even after the cracks started to emerge, they were able to hold together for a while until they eventually yielded. Again, this has more weak points than the double spline. When we compare this to the tongue and groove, the small profile of the tongue and groove, which is over here, that's its weakest point. So that's where it will start to buckle. And then its secondary point is over here. But it's important to note how quickly it buckles once that secondary point is yields. So as that secondary point yields, it comes apart quite instantaneously. Okay, so as mentioned earlier, the small profile is its primary weak point, but once its secondary weak point gives, it gives out instantaneously. Based on these tests, referring back to the moisture test where the single spline could perform comparatively to the tongue and groove, as well as the compression tests where we saw that it was distributing the forces towards the mass timber walls, as well as the bending and racking test where even after the cracks started to emerge, it held out for quite a while. Based on these, I picked the single spline joint for the assembly. For the floor and roof panels, I used the same typology as the wall panels using the cross-stack dowel laminated timber. The difference here, for the floor panel, I used 5-ply. This is based on a study conducted by the Department of Housing where they looked at average dead and live loads for residential buildings. And they found that it was on average about 55 pounds per square foot for floors and then 35 for roofs. And so based on that, I used 3-ply for the roofs instead. So these are also from the study with the U.S. Department of Agriculture and many organizations, including Woodworks, where they looked at different panel-to-panel connections for floors. So one of the ones that I came upon was the double surface spline for the 5-ply. These use plywood pieces, half an inch to an inch thick, depending on the need for the loads. So the double spline, the surface spline is applied for the longer profiles and the internal spline is applied for the smaller profiles. The same is used for the roof-to-roof connections, but instead using an internal spline for the smaller profiles. The wall, roof, and floor connections, these are based on the index that was produced by Woodworks by using their network. They have a network including companies like RDH, which focus on building science, mainly in Northwest United States. And they look at different assembly types and different connections. And one of the simplest and one of the cheapest connections is using partially threaded screws. So these are used for the roof-to-wall connections, as well as the wall-to-roof using a wooden ledger instead of any steel. And then for the foundation connections, both for the wall and floor, there's a pressure-treated sill that's anchored into a concrete foundation, and then is connected to the wall as well as the floor using partially threaded screws. As I mentioned earlier, RDH is a building science company that is based in Portland, Oregon, and San Francisco, and they're part of the Woodworks network. And they developed the groundworks for developing wall assemblies. And so referencing some of the information they provide, I came upon this wall assembly, which uses the mass timber panels in addition to cork insulation as well as cedar for its weather-resistant qualities. It also uses Graham vapor barrier, which is a technology that uses biopolyethylene, which is a relatively new technology. It developed around 2005, and it became a product within the past 10 years. It's relatively absent here in the United States. It has been developed in Europe, specifically in Scandinavia. There's a company in Norway that develops it, but it's rarely available here in the United States. But it uses biopolyethylene, which is an alternative to polyethylene. Instead of using petroleum, which is used to produce plastics, it uses sugarcane, in some cases corn, instead. The floor assembly is relatively simple. As I mentioned earlier, the mass timber is quite robust in terms of its R value, and so this is supplemented with the cork insulation, which is made from the bark of a cork oak tree. The roof assembly also uses the Graham vapor barrier with cork insulation as well as cedar shingles. Unfortunately, there is also a requirement to use ice and water shield, which unfortunately doesn't have a sustainable alternative at the moment. It's only found within a polyethylene, which is petroleum based, and it's an area to this that needs to be explored further. But the roof assembly alongside the wall and floor assembly, as well as the different connections, make up the kit of parts that we can work with to create different typologies. We have the opportunity to explore different openings by using the increments of the mass timber, using the increments of the 2x4s. As I mentioned earlier, these are structurally robust, so we have the opportunity to explore different types of openings. We also have the opportunity to explore different typologies, such as a single-family home, which can be aggregated into communities to fully take advantage of the mass timber. The panel-to-panel connections, as well as the floor panel, determine the grid in which we can work in. As long as we work within this grid, we have the opportunity to test out different spatial organizations. In this case, using it to create a courtyard-style single-family home. And when these different kit of parts come together, the robustness of the timber panel becomes quite apparent, where it minimizes the need for insulation, and where there is insulation needed, we can integrate cork insulation, which is a far more sustainable alternative to foam insulation, and we're able to meet the requirements for Climate Zone 4. Another assembly we can explore with this kit of parts are townhomes, which ask us the question of how we scale up, and we can explore that further. In addition to the grid determining the partition walls, it can help us determine how we can align vertical loads across the different levels. And in addition to meeting the requirements for the climate zone, we can integrate this connection. This connection is also from the study conducted by Woodworks, where we use steel plates to transfer the vertical loads. And this starts to think about ways we can expand this further, and we can start thinking about scaling it into different typologies. These kind of parts are relatively straightforward, but you're robust when it comes to sustainability. And it gives us the opportunity to lay the groundworks and create numerous possibilities, numerous opportunities to create sustainable homes and communities across the US. Thank you.
Anyone want to start? Thank you.
This was really great, a great presentation, and I feel like I learned quite a bit from it, so thank you so much. Congratulations. Really thorough investigation. I like that you did the one-to-one mock-ups and the testing, like really interesting to me. I have a couple questions about the structure. Can you tell me what the maximum openings can be? Like, you have these possible door and window options, but I'm wondering how far can they span? Like, these headers don't look totally conventional, so.
Yeah. So in terms of the span, it's determined by the ply, meaning like if it is 3-ply or 5-ply. So it depends on the question. So is it for the headers of the doors?
Yeah, so how big can you make an opening, or how wide can that window be?
Yeah, so I might be like one number off a little bit here, but for 3-ply, for 5-ply, you can get up to 13 feet using mass timber. This was done by, again, Woodworks, I believe, within their network. And so it all depends on the ply. So for example, for the door there, it has about 3-ply, so about 10 to 9. So it depends on the number of 2x4s.
Okay, so like the thickness of the
thickness,
assembly.
Exactly, yeah.
And yeah, I have so many questions, sorry. Do you know what the R value of just the laminated area is?
Well, I have it on there, but it's 1.4 per inch. So these have a total of 7.5 inches. So whatever that is multiplied gets you the R value.
Okay, yeah, that's good to know. I understand that these are sort of prototypical and you're more focused on the technology and the assembly aspects. So I feel like the architecture might be a little bit off limits, but I'm just gonna add that it'd be great to see these designs a little more hashed out in terms of openings and bringing, adding more windows just to make it look a little bit more like a real house. I think otherwise, I think it's a really beautiful and elegant sort of solution and use of wood in this single family home application. And even with the townhomes, I think we could maybe do an elevation. Like, I want to talk about the architecture. I know it's not like fully resolved, but I think maybe another layer would be to add more detail there and, sort of work out those designs. Especially in elevation for the townhomes. I think that would be really interesting. I think they're really compelling in the renderings, but just another level of information there. Otherwise, I'm really curious about how electrical is run, plumbing, all these other things. So yeah, just maybe another layer of information. Thank you.
Thank you.
Yeah, thanks a lot for that presentation. It was so thorough, and this materiality exploration is really cool. I love it. I think it's just really good to see you out there, like letting your aggressions out. You must be very calm today. But yes, I do think while these are prototypes, it is something to look at since they are smaller structures and there's not a lot of detail. I would say just sort of the overall planning. And while, yes, it's on a module and things can change, the courtyard is, is quite thin. And why not use the larger window all the way around and really create this, inside outside approach? That being said, the front door is literally like right on the street and there's no sort of transition. I mean, you're coming like right into the living room. So it might be nice to, it is 1,500 square feet, which isn't that small really, to have some sort of transitional area before you get into the living room. And then, I kind of feel bad for like the cooks in the kitchen because there really aren't any windows. I would just take out those walls and just open it up. Maybe you have floating walls in some capacity with storage or, build them out so they're a little bit more like substantial than just like a half wall kind of thing. There's a lot of hallway. It looks like it's like maybe 7 feet. I think I would give that to the spaces themselves. And thinking about just, bedrooms need closets, just basic stuff. I understand you're not like hitting every detail, but you are showing some furniture. I don't know where their refrigerator is. Do they have one? Yeah. But for a 1,500 square foot house, they should have a refrigerator, a full scale. So there's things like that. And yeah, I'm just kind of looking over here why, again, you walk into the living room, it's a very enclosed room. And then the windows are the smaller too. So, is that just for privacy on the street or were there fenestration design decisions based on, was it like a financial or how many windows, or were you thinking about the user and just creating, the best space possible? Do you know what I mean? Because that living room is going to feel very closed in. I would have just blown those walls out, had all the circulation on one side so you're not like zigzagging through in such a small space. Just thinking about, again, the bedroom spaces and that bathroom. I don't know if you need a tub in 2 floors, things like that really make that space just more functional in that sense. So that being said, what were your design decisions on the window sizings, like for the townhomes? Because you don't get a ton of light in those spaces.
Yeah, that's a good question. I think that's definitely an area that can be further developed. But I think it was basically defining the kit of parts that we can work with and saying like, these are the things that we could potentially do. We can expand on that. And then integrating that into an assembly and seeing like how we can assemble this structure. One of the main points of the thesis is basically setting the foundation, setting the groundworks, and saying these are the essential elements that we need to use, such as meeting the R values and things of that nature.
Yeah.
And then seeing what we can do with these assemblies. Once we have the essential elements figured out, we have a lot of room to explore in terms of creativity. So it's not bounded to these assemblies. It could be any number of assemblies. It's just all the important components are all figured out. It's just open to interpretation, I guess.
Yeah, no, I get that. I think because you just have these two and they are fully flushed out in the sense that you've got very realistic renderings, it might have been more interesting instead of this, just having process drawings where you're just, sketches of different options where you can see like a lot of different component types and configurations. So it's a little bit more, when you show a client this, it's like they expect that, which is why a lot of architects are like, okay, I'm going to get back to like more conceptual and collaging and stuff like that. I think when you have it so finalized, it just feels so finalized. So that's what I would say. But I do love the material exploration.
Thank you.
Yeah, wonderful work. The proof was in the pudding with the videos. So I think we all were really fascinated by looking at that. Can you talk a little bit about how, if there was this was going to the market, if you will, how people would know the assembly, like the actual, like I'm now on the site. How do people know how things really go together? Does that make sense?
That's a good point. Yeah, I think in terms of the assembly, much of it is done off-site for the panels, and then they're assembled on-site. And one of the reasons why I explored the connections as much as I did is thinking about how we assemble on-site. And one of the main reasons I picked the single spline joint is that the moisture, wood reacts to moisture quite a bit, and these grooves change quite a bit. And so it's ensuring that by using just the single spline with the grooves, we can adjust the spline according to the moisture of the area. And also using very simple and industry standard connections. So the wall to floor and these connections are all quite simple, or the most simple and cost effective ones. And so it's making the assembly process as simple as possible and making sure that we're using industry standards instead of inventing new ones.
So I think my only comment.
Yeah.
How does the roof not blow off?
For the partially threaded dowels, the screws, is that the question? So the screws themselves, this is from, mentioned earlier, I mentioned them quite a bit. There's a network of companies in Northwest that look at, and the company that, the organization that deals with these is Woodworks, and they provide an index for contractors to use in terms of these assemblies. And one of those assemblies is using partially threaded screws for the floor to wall connections. Yeah, exactly. These aren't, yeah. They describe it and they provide drawings to explain it, and I use that as my basis. Yeah.
So it looks to me, and you're the expert, but
Yeah.
it looks to me like that screw is going right into end grain, and there's 2/5 of the screw that's penetrating down into the wall. I think where I'm going with this is that there are a couple of places where the inventiveness of the assembly and the exploration is balanced against what you're learning about industry standards.
Yeah.
And there are some places where I think either it's not for this climate zone, for instance, in this climate zone, there would not be a polyethylene, even a gram vapor barrier on the exterior wall, because the wood can't dry out that way. In climate zone 4, it's not recommended anymore. So the places where the wall assembly or the connections and the connections of the assembly and the structure just either seem to be not quite fully understood by you, or they need a little bit more tweaking.
Fair. I did mention RDH did a very extensive exploration into this.
Do you know what they did? Did they do a hydrothermal analysis, for instance?
I don't particularly remember. I can provide you the information on that. But they did explore for Climate Zone 4, and they did say that these wall assemblies are applicable for Climate Zone 4.
But your job, this is your thesis.
Yeah.
And you presented the assembly as the basis for your thesis.
Mm-hmm.
So you have to expect questions that are going to require answers more than this group did the research and I took their research.
Yeah.
Because if this is your project, if this were my project, and I were taking responsibility for the design of it and somebody's going to build it, I really want to know those answers myself because my insurance company should be here.
Yeah, good point.
So I think it's very inventive. I think there are a couple of areas where if you understood the system a little bit, just a little bit more, or understood the underpinnings a little bit more, it could also go a little bit further.
Okay.
Yeah, I think you were bringing out really important points, really important questions when you're exploring novel assemblies.
Yeah.
So one of the things you hadn't mentioned is that this particular assembly is not a product.
Yeah.
The design guidelines you're using are for CLT or NLT,
Yeah.
metal nails. So you, in many ways, are kind of like bushwhacking, right? And so many questions
Yeah.
when you do that. Right? So we talked about in our meetings, like, at some point it's going to be important if you're interested in this becoming a product, that you will full scale mock-up and do moisture testing.
Yeah. 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 Yeah.
Thank you. Yeah, but yeah, that's the point. I guess the point I want to highlight is the one that you introduced, which is you've created, this is a kit of parts, or this is an approach, assembly approach. And but the thesis, I'm pretty sure I'm kind of paraphrasing correctly when you said, the thesis is about what you can do. You can do something with this. You know, you're demonstrating a use case in two different examples, but you can do something else with it,
Yeah.
right? The foundation of moving forward with that system is predicated on understanding the likelihood of success and what can be done with it to develop other iterations. So really, I think the broad point I'm trying to make is you, and I'm getting a little bit more information now from what Yanda said, you applied a system to a climate zone. You applied a system that's used in other climate zones, not in this country, to this climate zone.
It is used in this climate zone. I think the point, Yana mentioned this as well. The difficulty is that much of this isn't developed for the United States in general, but it is developed with other typologies of mass timber, like NLT, for example, or glue lam. So those are obviously different to dowel laminated, which is what I'm exploring. And so it is a tricky situation where I don't have it developed, I don't have it tested out there. And so I'm left with using the indexes that are based on CLT as well. And when I apply it onto this, you mentioned there's a great deal of questions as to like how effective could this be? Could this really be applicable? That's definitely the point. But it is applicable to the United States, but not for DLT. I guess that's the explanation.
There are other mass timber products like glue laminated,
Exactly.
cross laminated timber, or metal nail laminated timber that are products that are available. And some of these details and some of the structural testing has focused on those products.
Exactly.
You're looking at an all wood product, and you're looking at using CNC routing to use kind of like forest thinnings and waste wood in the East Coast. So you're adapting some of the existing details, and then you're trying to develop this new panel type that you think might have a market.
Yeah.
Yeah. That's great. Yeah.
Thank you. I'm curious how you landed on the 2x4 as sort of the root unit measure, because I'm wondering if there might be either greater efficiencies or less efficiencies that you might have explored in the dimension of those base units. I mean, in general, I'm curious to understand sort of the like carbon footprint of, I understand wood being relatively sustainable and that's also carbon sequestering, but understanding sort of the footprint of something that requires so many discrete units in its initial production.
Well, the 2x4 profile can change, but similar to the connections, it's going back to what's cheapest, what's simplest. And the 2x4 is generally the cheapest strip of wood we have. So again, it's going down to trying to make this as accessible and as cost effective as possible. But it is as viable to use a 2x6 or anything. Like it doesn't change the overall composition by much. It just changed the increments in which we work for the openings and things of that nature, but it would be as effective with a 2x6.
Yeah, I mean, just thinking about how many dowels you would need, that you would 2x4s would require 50% more dowels than a 2x6 theoretically.
Yeah.
So just thinking about that. And then my other comment was just really kind of looking at sort of the assembly as from one unit to another. Also looking at the vertical plane, not just at the roof, but between floor plates. And so I'm seeing in here, it almost looks like it's one continuous thing, but they really are stacked on top of each other. And so it'd be wonderful to kind of see the exploration that you've done in plan for those connections in section as well.
I just have a couple questions. The joint, how is it attached to the panels?
Which joint?
Any of those joints you have there, the double spline joint, the single spline joint?
Oh, those joints.
Yeah.
Those could be nailed into these
Okay,
panels.
so
or-
just like the illustrations to the right of it. Okay, and then just another question, and maybe I'm not reading it, but this one, is that a crawl space where, instead of a concrete slab, you have wood? So is there a basement or a crawl space?
Oh, no, there isn't. There isn't.
Well, you probably wouldn't put the wood on the earth, right?
I believe there's gravel and some open. I think the detail might be missing a little bit from
I don't
there,
see
but
anything, it's
yeah.
just,
But there would be.
there's a
gravel
ledger
underneath.
board, so it's meant to,
Pressure
the
treated
concrete
ledger board
wall
attached-
supports it.
Yeah.
It's just a question. I wasn't sure if this is meant to be, above the grade, the earth. Um, It's
Yeah.
air. Okay. All of this was, sorry, what's that?
Seems like on the outside, the grade needs to be like 4 inches below the wood.
Yeah. Which actually goes to the next point, is that you did all of this technical investigation and, testing and all of that, which is maybe a little more engineering than architecture. But then when you got to the architecture, you kind of dropped the ball a bit on the layouts. So maybe a little bit more time should be spent on, as was mentioned earlier.
Yeah.
So again, when it's a row building, just like what I asked earlier on one of the other projects, do they share wall? When it's a party wall, they share wall.
Yeah.
Okay. Well, it might be good to show a number of them together to convey that. Thanks.
Thank you.
Thank you. I found this analysis, congratulations, it's really interesting for me. Both of my theses, my master thesis and my PhD thesis, were experimental theses, so I was very pleased to see your work. So I have a few questions on your testing. It seems to me that the most effective testing that you conducted was moisture absorption. How many samples did you place in water and for how long?
So I used 3 samples of each one and placed them in the water for 24 hours.
And left them to dry for?
No, it was after they dried for a couple of hours, and then I measured the volume for
Okay,
before and
so
after
3 per joint type.
per joint type.
And this is true also for your compression testing and for your bending testing. So, okay, so you did a minimum of 3. And I see you brought some of the samples. Thank you, that's gonna be interesting for me to see later. And the compression, usually the compression that these joints would be subjected to, we're talking about support, right? Or the weight that they need to carry. So that's slightly different from a testing point of view from the mallet that you were using. So compression that is sustaining either the floors or the rooftops, or just general use of the building is slightly different than this is like a mechanical action, whereas that is right. It's slightly different. The impact it's like an added weight to it, so it's not exactly the type of load that this. However, that being said, it's interesting also to know if something were to fall with that kind of impact, right? How the joints would react. And the bending as well. I don't know how much of a access you had maybe to like any kind of machinery that could do the bending for you. None. Okay. Because that depends on where the bending is applied, right? And maybe this would be wind or earthquakes.
I think one element that I hoped I had was something a bit more controlled, so that it was consistent across the board instead of just based on my pulling force. I just to have each of them subjected to the same force at the same location. But it's hard to do that without any mechanisms for it.
No, the machinery is absolutely fundamental. So I think that's why I was saying before, the most effective was the moisture. So I think, all right, so this is my input for your testing. Since the moisture test was, for me, the most effective and most interesting one, it could have been like, let's take it one step forward, and you waited 2 hours, and then you do it again the next day, and see how much of that extra volume was lost. And that's one of the most important qualities. There is moisture absorption in all of construction materials. So we have that in mortar, in bricks, in reinforced concrete, and that's to be expected. What we need to know is, okay, it gains this much volume, when does it lose it? Thank you.
Thank you.
Thank you so much for your presentation. First part I found really interesting, your test. I agree with Daniela about your presentation. So my thought is about other two considerations. We talk about with colleagues about architecture. I would like to talk about maybe two typology, because I appreciate the fact that you present two different typology. One is the row houses, and the other one we can call a freestanding or inline house. For both categories of typology, I suggest to go a little bit more deeper, because especially when you analyze row houses, you have already a lot of example that works very well. For example, in Italy, in Europe, but I think also in the United States, you have to respect some standards, some regulation. So, for example, dining room without windows is not possible to design. So the second thought is about maintenance. Because it's very interesting, this technology. I know from Northern Europe. And also, every time that you use a timber structure, they also think about how it's possible to maintain with several kind of metal sheet that could be used in details, especially in the facade and the roof. So, especially when the wooden is in contact with the ground or with the grass, with the with the water, basically. So I wonder if you consider some gap just to detach the double skin facade that you use. That could be interesting for maintenance. And then maybe for this reason, I will appreciate some notes that you mentioned in the section probably could be more developed in order to understand the structure, how it works. That's my thought.
Thank you.
Thank you.
Thank you. I have to say I wasn't expecting this level of detail, and I really appreciate the depth you went into to assess this wall type. And I do have a few questions about that. I don't think that the architecture meets the standard of design, and I'm not sure I would have spent my time doing that. It looks like that was an afterthought, not really thrust of your presentation. It doesn't convince me that this is a good wall panel if that's the result. So I'm not sure I would have spent the time there. Maybe the thesis should have stayed within trying to get into all the other details and how this works. and including perhaps a life cycle analysis and the whole labor intensity of this compared to traditional walls, because if fundamentally it's a product, it does have to have an economic advantage or does need to meet some standard of economics. You talked about like the weight, you could perhaps use a smaller version, right? But labor becomes intensive if one person, you know, a single person can frame a house in a bunch of 2x4s. But if I need 3 or 4 people to lift that at the same time, you know, what's the labor time that's offset by that? I do think that's an important part of it. And then the other side of this is the nature of wall panels. And, you know, what's beautiful about CLT is that I get the benefit in the ceiling. I get to see the wood, right? It gets complicated with other utilities and things like that that start to undermine its value. But is this a good wall surface? Like I'm looking at the rendering here and assuming that they're the wall panels. Am I going to see all the joints, and can you play with the different color dowels? Can you mix it up to think about how it could become some type of architectural expression, and what's the value of it in terms of, you know, what it does? So I'm struggling because I really appreciate this. I wish you would have answered some of the details that were asked and have known it. And yet I don't think you spent enough time on that. I'm not sure I would have probably spent my time over here. It looks like that's where your real interest is. And therefore, I think that would have been more provocative as a thing to, you know, focus on that as an issue. So thank you.
Thank you so much.
So many great comments. I'm just taking some notes. Some of the most interesting comments, I think, today were about showing your process drawings. Maybe instead of showing the kind of finished, set in stone typology studies, I think would have been really interesting, and maybe responds to this last comment here. I think the conversation about, you know, the wall assembly and things like the thermal value and vapor barrier, depending on the climate zone, is a really interesting, rich one. So I'm glad that came up today. Compression as something sustained, and the moisture testing. I think those are all really great pieces of feedback for you as you continue, hopefully, with this work. Maintenance and thinking about the typologies that this could be used for. And I love this last comment about the aesthetics, right? That in some ways you're introducing a new aesthetic for residential typology that's not about drywall, but it's about wood and connections. And so what are the studies there? And, you know, maybe you move this from an engineering exercise into something that's really feels like it's in the terrain of architecture by thinking about those aesthetics and what you're introducing by introducing these panels. So I had such a great semester kind of like following you in this process and watching you do the testing, and I think you really dug in. So yeah, I was honored to be along this path with you. Thanks so much.
Thank you.
Okay. Congratulations to our 3 morning presenters on completing your thesis process. And thank you for your presentations and for including us. If you are a student who has or has not presented, your job now is to quickly pin down and help others pin down and pin back up. We'll start again at 2. If you are not a student, follow the train upstairs. We'll have lunch together and catch up. And like I said this morning, if you have any questions, you can ask me or ask someone who knows like they know the answer.